What is the XRPL cluster, and how does it work in layman's terms? When we talk about the XRPL, many think about validators as the main backbone of the network that keeps everything working. However, the picture is way more complex than most people would imagine. With the recent announcement of the overhaul of the cluster, I want to shed some light on what the XRPL cluster is, how it works, and why it plays such a crucial role for the XRPL. Whenever you open some wallet, use a service, deposit or withdraw XRP or casino coin from rnr.poker, or an exchange or marketplace, there is a high chance that your requests or submissions are sent to the cluster. The cluster offers a single access point via a WebSocket connection to interact with the XRP ledger. The cluster is a popular alternative to running your own infrastructure, allowing you to get data in and out of the ledger. While it is highly recommended to use your own infrastructure, it is only viable for some to do so. How does it work? The cluster is a sophisticated guide for navigating information requests and submissions through a vast, globally dispersed network of servers, ensuring your data takes the most efficient and available path possible. It also ensures that requests are evenly spread throughout the network of nodes, ensuring maximum efficiency. The potential failure of single nodes is mitigated because multiple nodes are available for specific requests. When a user initiates a query or a data submission, their request first travels through Cloudflare, a prominent web infrastructure and website security company. Here, rather than employing standard load balancing via Cloudflare, a technique for distributing workloads uniformly across servers to prevent any single server from becoming a bottleneck, it utilizes the geographical proximity of the user, directing the request to the nearest edge server from among 7 potential edge nodes. Once a request reaches the closest edge node, it encounters NGINX, a highly efficient HTTP server and proxy. Subsequently, the query dives into a specialized custom-coded middleware developed by XRPL Labs. The middleware embeds a routing logic, an intelligent set of rules and pathways specifically engineered for routing traffic. It ensures that the data is routed astutely based on the query type and the available nodes within the network. The middleware discerns the nature and requirement of the query, leading it through the most logical and available path to the relevant RippleD node, specialized servers that manage and sustain the XRP ledger. The network, thus, adapts dynamically, directing different query types and data submissions to various node types, such as full history, nodes, or others, based on current availability and specific requirements. For instance, different node types will handle pathfinding and ledger submission tasks to optimize network performance and reliability. Intriguingly, the system also incorporates intricate layers of security and traffic management to navigate through myriad challenges, such as distributed denial of service, DDoS attacks, spam, and other forms of network abuse, substantially elevating the complexity of its operation. What about security and availability? Between Cloudflare and the back-end proxies, primarily through NGINX, several logging and detection layers are seamlessly integrated, diligently monitoring, logging, and analyzing the traffic that transits through the network. These layers are perpetually in dialogue with Cloudflare and the edge nodes, making informed real-time decisions regarding the traffic. By employing advanced algorithms and heuristics, they discern legitimate user traffic from potentially malicious activities, determining whether specific traffic should be allowed, throttled, or outright blocked. This vigilant approach ensures that all nodes remain available and optimally functioning, preserving the integrity and fluidity of user transactions and interactions within the network. Consequently, this enhances the overall stability and reliability of the system amidst the chaotic ocean of digital disturbances constantly bombarding the infrastructure. How much is the cluster being used? To give you an idea of the amount of data the cluster is handling, here are some stats from September. 2.95 million unique IPs requested or submitted data, which amounted to a total of 286.227 million requests, translating into over 20 terabytes of data being served. The top 5 geolocations for requests are, based on requests per 7 days, USA with around 16 million requests, Germany with around 12 million requests, the Netherlands with around 6 million requests, Belgium with around 5 million requests, Japan with around 4 million requests. Based on these figures, the cluster dealt with an average of 110 requests/submissions per second during that time frame. Conclusion. Now that you understand what the XRPL cluster is, how it operates, and how much workload it is handling, you might understand why it became a core component of the XRP ledger. Remember that dozens of people outside of Ripple and RippleX commit their time 24 hours a day, 7 days a week, to ensure you will never notice even the slightest hiccup when interacting with the ledger. Even if you notice some minor issues occasionally, be assured that these people will do whatever needs to be done to find a solution. If you enjoy explainers like this one, share them with your friends and let me hear your thoughts.